Sumaylo.
Hi, I'm Mitch.
It's Mohammad Sharief.
Let our example be f of x is equals to x cubed plus 3x squared minus 2. This function was taken from a book Calculus 9th edition written by Ron Larson and Bruce H. Edwards. Next, we will describe the function by discussing on its variables. The function has important variables. The x variable is the independent variable or the input or domain, and f of x is the dependent variable or also called the output or range. Next is, let's assume a number a. Find the limit of the function as the independent variable approaches the chosen value of a. Geometrically show the limit of the function as the independent variable approaches to the chosen value of a. Find the limit of the function f of x is equals to x cubed plus 3x squared minus 2 as x approaches the 2. So the limit of x cubed plus 3x squared minus 2 as x approaches to 2 is equals to, just substitute x to 2, which will turn out like this. 2 cubed plus 3 times 2 squared minus 2. So the limit of x cubed plus 3x squared minus 2 as x approaches to 2. 2 cubed is equals to 8 plus 3 times 2 squared is equals to 12 minus 2. Okay, so the limit of x cubed plus 3x squared minus 2 as x approaches to 2 is equals to 18, as 8 plus 12 minus 2 is equals to 18.
So for number 4, we're going to derive this function using the 4 step. So, step 1. We added a delta y in our equation. As you can observe, the x in our original function was replaced as x plus delta x. So y plus delta y equals x plus delta x cubed plus 3 times x plus delta x squared minus 2. Step 2. Going to eliminate the y, we will transfer it to the right side. So the delta y will remain equals x plus delta x cubed plus 3 times x plus delta x squared minus 2. Then the y going to transfer it to the right side, so the sign will change from positive to negative and negative to positive. So negative x cubed plus 3x cubed, and negative 2 will going to be positive 2. So we're going to simplify the equation. So we're going to factor x plus delta x cubed and also the x plus delta x squared. Need to factor that first, then times to 3. Then copy the negative 2 minus x cubed minus 3x cubed plus 2. And then combine like terms. And for those numbers that will simply answer 0, we're going to cancel it so that we can get this answer. So x cubed and negative x cubed cancel. Negative 2 and positive 2, as well as negative 3x squared and positive 3x squared. So that will answer 0. So we're going to cancel it. Then continue the 2x squared delta x, and this one we're going to answer this one. Then this one and this one are going to result to this one, plus then we're going to combine this and this will be the result, and the remaining 6x and delta x. Step 3. So dy over x equals, so this we're going to divide both sides by delta x. So it will remain 3x squared plus 3x delta x plus 4 delta x plus 6x. So step 4, as delta x approaches to 0, so the delta x here we're going to replace it to 0. So 3x squared plus 3x, 0, plus 4 times 0 plus 6x. So the remaining is 3x squared plus 6x. So this is the final answer. So for number 5, derive the function f of x equals x cubed plus 3x squared minus 2 using the standard form. So this method is the easiest way and also we have commonly used. So let's put down the 3 as a coefficient, then 3 minus 1 plus the exponent 2, we're going to have this coefficient, so x 2 minus 1. So the negative 2 is here is a constant, so it means it's zeros. And the final answer is 3x cubed plus 6x.
So here is our function and our point. This point is from this function, the graph of the function. So we need to find our slope. So in order to find the slope, we need to find the first derivative of the function. So y is equal to x cubed plus 3x squared minus 2 at given point 1, 2. So dy over dx equals, you will bring down 3, x 3 minus 1 plus 3, bring down 2, x 2 minus 1, and the derivative of a whole number is 0. So dy over dx equals 3x 3 minus 1 equals 2 plus 3 times 2 6x 2 minus 1 1 0. So here is our first derivative. In order to find the slope line, we need to equate our points. So we have only our x here, so we will equate only the x. So 3x will become 3 times 1 squared plus 6 1 times 1. So 1 squared is 1 times 3 3 plus 6 times 1 6, which is 9. So here is our slope. So we all know that the normal line is the negative reciprocal of our slope. So our normal line will become negative 1 over 9. So we'll put that here. 9 negative 1 over 9. So after finding the slope and the normal line, we need to find the equation of the tangent and the normal line. So in order to find the equation, we need the slope, the point, and the formula, which is we will use the point slope formula. Y minus y sub 1 equals m times x minus x sub 1. So we will just equate our slope and our point. So y minus y sub 1 is our y, which is 2. M is our slope, which is 9. X minus x sub 1, which is 1, our x. Then y minus 2 equals, we will just distribute this one. It will become 9x minus 9. And we will transpose this 2 to the right side. Y equals 9x minus 9 plus 2. Combine like terms. Y minus 9x minus 7. So here is our equation for the tangent line. The equation for the normal line is the negative reciprocal of our slope. So same thing. Y minus 2. So our m here, instead of 9, we will use negative 1 over 9. X minus 1. So y minus 2 over, just distribute this one, so it will become negative 1 over 9x plus 1 over 9. Next thing is 2 transpose. So y equals negative 1 over 9x plus 1 over 9 plus 2. Combine like terms. 1 over 9x. So the sum of this 1 over 9 plus 9 is, so 19 over 9. Here is our equation for the normal line. That's it.
So number 8. We will now discuss our critical points, minima, maxima, concavity, and inflection point of our function. Let's go. If we will now look at on our graph, we can see that our critical points are at point -2, 2, and 0, -2. As x increasing passes through -2, y changes from positive to negative. Thus, y assumes a maximum value 2, and that can be seen at point D. And also, as x passes through 0, y changes from negative to positive, and y assumes the minimum value -2. It can be seen at point E. Next, we will now discuss our concavity and point of inflection.
So before we find the concavity of our function, we will find first the second derivative of our function. First derivative is 3x squared plus 6x, and our second derivative is equal to 6x plus 6. Then let f of x of the second derivative is equal to 0. 6x plus 6 is equal to 0. So 6x, then transpose 6 into the right side, so it will become -6. And then copy So now we will find the x. So divide 6 both sides. So cash out and crush still negative 1. So we have here our negative 1, assuming that we choose negative 2 and positive 3 on the left side and the right side of our x. So example, this is our negative 1. So this side we will choose negative 2, which is negative. So, and on this side we choose positive 3. So from this we will now substitute negative 2 and positive 3 to our second derivative. So our second derivative is f of x equals to 6x plus 6. So substitute now negative 2 is equal 6 times negative 2 is equals to negative 12 plus 6, and that is equal to negative 6, which is negative 6 is less than 0. And then now we will substitute positive 3. So copy. So we have here 6 times 3 plus 6. 6 times 3 is equal to 18 plus 6. 18 plus 6 is equal to 24. So 24 is greater than 0. So since negative 6 is less than 0 and 24 is greater than 0, therefore we conclude that the second derivative is less than 0 is concave down on negative infinity and negative 1. So our second derivative that is greater than 0 is concave up on negative 1 and negative infinity. So our next is that we will now find the points of inflection. So to be able to find this, we will use the second derivative. So our second derivative is f of x is equal to 6x plus 6. And now let f x of the second derivative is equal to 0. So looking back on our previous clip, we already solved this and we got negative 1. So I'm going to show you this again. And now we will going to substitute negative 1 to the function. Again, f of x is equal to x cubed plus 3x squared minus 2 is our original function. So now, let us try to substitute negative 1. So, therefore, our point of inflection is negative 1 and 0. So, In our graph, it can be seen at point B. So that would be all, guys. Thank you for watching, and I hope that you've learned something on this video. So if you like this, please give up a thumbs up and comment down in section. Comment down and give us a comment on the comment section below. Adios.